Welcome to Khetztutorials, and this is another video in the Python for Beginners series. In this video, I'll be talking about lists. So I've already created the file list.py. You can just go ahead, press this thing, create the file, name it whatever. I just named it list.py. Now, what are lists and what do they do? So I did cover lists briefly in the variables video. I just link it on the top right. So lists basically allow you to have a collection of items or elements. So when we talked about variables, you knew or you saw that you had a variable, let's say x, and it was assigned one value. Now with lists, we're saying that we can use the same x, which is a variable name, but assign a bunch of values. So value 1, value 2, value 3, and these values in here can be of any data type. So we can have strings, we can have even lists inside lists, we can have ints, we can have floats. All those data types can be put inside the list. So now a list basically is a collection of items, and we want to have multiple items associated with one variable or one variable name. So I thought of this example. Let's talk about colors. Let's say you wanted to talk about a few colors. So let's say we have red. And this is how you define a list. You're going to have these square brackets. So the equal sign, the assignment operator, then you're going to have the brackets. Inside the brackets, you're going to have each of the items that are associated with the list variable. And with these things inside, you separate each item with a comma, as you can see. So we have red, we have blue, you have, let's say, black, yellow. I'm going to put yellow next. Any number of values that you can think of. I'm just going to stop here with magenta. Now this is a list, and this is how you define a list. You're going to have a variable name, you're going to have the assignment operator, then you're going to have the square brackets. Inside the square brackets, you're going to have your items. In this case, we have quotation marks, which should tell you that each of these items is a string. So we now have all of these items associated with the variable name colors, and this is a list. We can confirm that this is indeed a list by using the type operator. If you remember the type operator, just going to say print type of colors. So what type of variable is colors? That is what we're checking right here. So if you look at that, it says class list. So this is indeed a list, and we've created a list. Now, what is the use of this, or why would we want something like this? First of all, I did say that we have a collection or a bunch of values associated with this. So instead of saying color underscore 1 equals red, then color underscore 2 equals blue, and so on, we have just one variable that stores all of the different values that we may want. And this saves space, and we don't really have to worry about having a separate variable for each value. And we can also access each of these things, even though we just have one variable name. So you might be asking, how do we exactly do that? So before we get into that, in most programming languages, the first point, or this is called an index. What we want to talk about now, it's called indexing. So we use indexing, and the plural of an index, we have indices. Now we start at 0. So we start counting at 0 when you use indices and not 1. So if I want to access the first element is at position 0. The second element is at position 1, and so on. So for these ones, you can see that this is 2, this is 3, and this is 4. We have a total number of elements. The total number of elements is 5, but to access each one of them, starting at 0, the last one just has to be 4. So that is just a rule which you have to know. So now, how is that useful to us? Let's say we wanted to access black, and we said that we start at 0. So what index is black at? So this is 0, this is 1, this is 2. And now if I say that print colors, and we're going to use these brackets to access that value black, and we said it's at index 2. So this is how you access a single element. So use the same variable name, and we can extract or we can take out whatever it is that we want. Currently, we're looking for black. So let's see if we can actually extract black using this. So if I print that, I expect the result to be black. And if you look at that, it actually is. So you use indices, you put your index in there. It's a number, an index is a number, which you put in there to access a specific element in your list. So that is just the basic principle of using indices and how you can actually access any of these. So you can put in any number as long as it's a valid number. So try using an invalid number and see what the result is. That is just an experiment which you can do for yourself. So this is 0, 1, 2, 3, 4. Try 5 and let's see what happens. So you can view that as some sort of homework which you can just investigate. Also, try something which is negative. Try -1 and you find something interesting if you try that. So you can actually do that and you just investigate for yourself what actually happens in that case. But for this tutorial, I just wanted to show you that you can use numbers to access different elements. So if you put 3, it's going to go to the next one. If you put 4, it's going to go to the next one. And that is how you access the individual elements which are in the list. Now, in most programming languages, you have arrays, and arrays basically follow the same principle, but usually they have a fixed size. So the size of this list is determined by the number of elements, and you can actually check that. If you don't want to manually count, you can actually check the length or the size of a list by using this len function. Just say len and the bracket, then you're going to put the variable name inside, which is colors, close that, then close the print statement. So this should give you the number of elements. If you look at that, it's 5, and if we count manually, we have 1, 2, 3, 4, 5 indeed. And after counting, we have actually confirmed that we have that exact number of elements. So that number is not fixed. We can either add or remove values inside a list. So that's one cool thing that I like about Python, because you can actually add and remove, unlike in other programming languages where you have to do a lot of extra things. So how do we actually add? Let's start with adding. But now we want to add at the end. This specific function adds a value at the end. So let's say we want to add silver. So append, when you say colors.append, you're actually adding the value to the last part or to the end of the list. And if you do that, we expect the value to be here. So it will be added there. We'll have silver over there. And now the brace will close after that. So this will be transformed into a comma. And we now have 6 elements with silver at the end. So this is our expected result. Let's see if this does exactly that. So you can print the list, you can print the whole list, as in all of the elements in the list, by saying print colors, or whatever name that you use for your own list. In this case, we have colors, that is why we said that. So if I print colors after appending silver, you'd see that silver is added into the list, but at the end, because that is what append means, or that is what the function append does, it adds silver to the end of the list. That is what happened with them, right? And what if you want to add at a specific index, or what if you want to add at a specific position, if I were to rephrase? So let's say you wanted to add silver, maybe there after blue. So you wanted to have red, blue, silver, black, and everything else as it is. Now what you do is you'd use another method, or you'd use another function called insert. So let's replace this append. So you now know how to use append. Let's see how we use insert. And now this insert doesn't replace whatever with, so let's count the indices. So this is index 1, 0, sorry, this is 1, and over there we want to put silver. So this will be index 2. So currently at index 2 we have black. So when you say insert, it won't replace black, but it will just shift whatever was at that index and actually put in silver. So expect to have red, blue, silver, and black. So the black is not replaced because it was previously at index 2. It's just shifted to the right and silver takes its position. So that's something that you have to know. And so how do you use this insert? You specify where you want to put. So if you just rewrite this, you'd see that it suggests that you have to put the index, then you have to put whatever it is that you want to insert. So let's start with the index. We said we want to put this at index 2, right? So if we put that in index 2, the current position of black, and what do we want to put? Silver, for example. And now let's print the result after inserting at index 2. If you look at that, it says red, blue, silver, and black is still there. It's not replaced. It's just shifted, and silver is now at index 2 because we said that we have 0, 1, and 2. This is index 2. So that is where it will be placed, or that is where it will be inserted. Now you might be asking then, okay, I know how to insert, I know how to append, but how do I replace if insert won't replace a value for me? So in the place of black, just like I said, let's say you wanted to put silver, and now you'd use this operator, which you also use to access the element. So when you do this, you're accessing the element, which is currently black. So if you want to print this, you're just going to print it just like that. Also, if you want to modify it or change it, then you can just use that as well. So now if I say colors with an index equals something else, then it will replace whatever was at that position, because this is how you access the element at a position. So we're saying black must change to silver. And now if you print colors, after doing this, we expect black to vanish or to be modified or changed to silver. And that is exactly what happened if you look at the result down here. So we now know how to append, which is adding to the end of the list, how to insert, which is adding a value anywhere in the list without replacing, and now you also know how to replace a value. What about removing? Let's say we want to remove a bunch of stuff in the list. Let me just erase that so that we can get to where we remove. So also with the case of deletion, we also have a function that we can use to delete at the end, but now it's called pop. And what this does, it pops the value which is at the end if you do not specify any number or any index in here. So if you just say a list dot pop, it will just erase or remove the last element. So let's see the result after popping. So let's see what colors will be after we pop that element. So if you look at this, there is one less element in the list, and the last element was the one that was removed from the list. So that would mean that we've effectively removed the last element by calling this pop function. But if you want to remove at a specific index, for example, let's say we want you to remove blue, which is at index 1, then you'd say pop 1, and let's see the result of that. We want to remove blue, and it did exactly that. So red, black, yellow, magenta, which means blue was removed from the list. So you now know how to pop the last element, how to remove the element at a specific index. Now, what if you know what you want to remove, but you aren't quite sure about its position or the index that it's in? Not to worry. Well, you have a method for that, and it's called remove. And with this, you're going to specify the exact element that you want to take out. Let's say we wanted to, what can I pick? Let's say yellow. So you're going to specify the exact element that you want to remove without even worrying about where it is in the list. So if you remove that, then you're going to run this, and after that, you see that we don't have yellow anymore because we specified that we want to remove yellow. Now here's an exercise for you. Because I didn't mention this, so let me first mention this. You can have duplicates inside a list, right? So you can have, let's say we want to have red again. So that's what I'm going to do. I'm going to add red over there. And then I'm just going to print colors so that you can see that lists allow duplicates. So duplicates, that would mean that the same value appears more than once, and red is there and another red is over there. Now here's an experiment for you. Try to call this method remove. Let's say remove red. I won't run it right now because, as I said, it's an experiment for you. Just investigate what this will do and just find out for yourself. So that is just some homework for you. And you can just check what happens if I specify that I want to remove an element which has duplicates or which appears more than once, and you can just check that for yourself. Finally, in terms of removing elements, you can also remove all of the elements in a list. So let me just remove that duplicate. You can remove all of the elements in the list by calling the method or the function clear. So now if you do this, you shouldn't specify a value inside the brackets. You're just saying we want to clear the whole list, and what that will do, it will return an empty list, or it will clear everything inside the list. So everything will be erased, and you just have these brackets over there, which just symbolize or just show that you have an empty list. There's nothing in the list. And another thing about Python is the functions are quite clear. The pun is not intended, but the functions are clear. Once you read this, it says clear, which kind of explains what you expect it to do. It clears everything inside the list, and that is exactly what it does. So let's go through everything that we talked about in this video briefly. We talked about defining lists, how you put elements inside the list. I also mentioned that you can have any data type. So instead of colors, if you want to name it something else, you can say age, for example, or ages. And in here you can, so let me not change that. I just want to do this quick example. You can have 1, 2, 3, 4, 5, and 6, for example. And you can have, let's say, values. I don't know what I could call something like this. You can have Boolean values. What I'm basically saying is you can have any data type inside your list. And here's a cool thing. You can mix data types, even though true is not a color, but let's just put it in there just for the sake of putting it in there so that you can see that you can mix data types. So here you have strings, but here you have a Boolean value. You can also add an int if you want, 300. And if I print that, it won't give me an error because this is a valid thing to do. You can do that. You have true, you have 300 in there, and that is valid. So first of all, you learned how to define a list, the syntax associated with lists. A list can hold multiple data types or any data type for that matter. You can also have a list inside a list. And now recently you learned about an empty list. So you can clear the list this way. You can either say this, or you can call the method or the function clear. That's another way. So you can define a list like this. Initially, it has nothing. This is how you signify an empty list, a list that has no elements in it. And now you learned how to add to the end of the list. You learned how to insert at a specific index. You learned how to remove the last element, how to remove the specific index, as well as how to remove a specific value in the list, how to replace an element, how to clear the list, how to check if a variable is a list. And now we're down to the end of the video. So that is just a brief overview of what you can do with lists. There's a lot around these things, and trust me, this is just an introduction, but with this information, you can do a lot of amazing things. So I hope you found the video useful. If you like the video, just give it a thumbs up. And if you haven't subscribed, please consider subscribing, and I'll see you in the next video.